Namaste. Good morning, ladies and gentlemen. Warm welcome to Renaissance Convention Center Hotel. Before I take you to my safety speech, let me introduce myself. My name is Manoj Singh, and I'm working as a loss prevention executive. This hotel is equipped with automatic and manual fire detection and suppression systems like smoke detector, heat detector, fire hydrant, portable fire extinguishers, manual call point. Today there is no mock drill. Hence, any alarm should be taken as a genuine alarm. But no need to worry. When our hotel management feel that evacuation is necessary, announcements shall be made all public announcement systems. At present, you are in Grand Ballroom. There are 7 fire exits. 3 from behind, 3 from front side, and 4 from back side. Once you hear evacuation, go out from this room, take right, and move toward convention glass door, just now from where we have entered. Opposite convention glass door, there is evacuation assembly point. At the assembly point, we will conduct head count and roll call. For medical emergency, hotel is tied up with top ambulance, and the number is 1252. I will repeat the number, 1252. Doctor on call is available in the hotel. That's it from my side. Any questions? Thank you very much. Have a nice day.
Hello, good morning, and a very warm welcome to all of you to Innovation Day 2019. Innovation Day 2018 was a huge success, and here we are welcoming you all back to Innovation Day 2019. Today is all about showcasing innovative technologies that help industries use data and in a manner that can be used to maximize the potential of digitalization. I now invite on stage Mr. Sunil Mathur to give the opening address. Mr. Mathur.
Good morning and a very warm welcome to all of you. Special warm welcome to our chairman, Mr. Parekh, members of the board of Siemens Limited, customers. We also have here members from the press and also our analysts as well. So the word digitalization in India is gathering momentum. I think there are many more companies wanting to understand what exactly digitalization means. There are phrases being thrown out there: artificial intelligence, Internet of Things, Industry 4.0. How do all these come together? Many companies and many people are not really sure. There are a lot of apprehensions. What does this mean in terms of real benefits? Is this a nice to have, or is this really an imperative? What is the real benefit that comes out of it? There are questions around jobs. What does it mean in terms of jobs over here? There are questions about the long-term impacts that this will have and security issues. So how is all this data really going to be secure? This is the second Innovation Day that we are having, and over the course of the day, I hope we can give you a little bit more clarity about some of these issues. From an Indian perspective, you are all aware the government has talked about Make in India, is talking about increasing the share of manufacturing from 15% of GDP to 25% of GDP. Now, what does that actually mean for India? 15% of GDP today, GDP $2 trillion, 15%, $300 billion. At 7 or 8% in a short period of time, we will get from 2 trillion to 4 trillion. The ambition is 6, but let's start with 4. 25% of 4 trillion is $1 trillion. So you're going to have $700 billion of contribution to GDP coming into the Indian economy. Now that means at least twice that amount in terms of capex. So we are really looking at close to $1.5 trillion of capex coming into the Indian system, within the next couple of years. Now, this will not be possible without digitalization. The global arena is talking about digitalization, is implementing digitalization, and we are already having factories and manufacturing premises which are talking about 99.99% productivity, quality, and so on. So India cannot afford to be left behind on this. The $1.5 trillion that we will produce of capex over here will not be adequate or will need to lead to exports. The Indian consumption system will not be able to absorb that, which means we will get into competition with global players. And global players are all implementing digitalization. So it is really an imperative for us here in the country to really understand what this means for us. From a Siemens perspective, we wanted to showcase this for ourselves first. And we looked at our factory in Kalwa, a typical brownfield factory, 50 years old, recently celebrated its 50th year, very typical to a factory which is an old factory, brownfield in India. And we looked at one of our product lines, contactors, that we produce over there. And we said, how can we enhance the capabilities of this and really showcase what digitalization can actually do as a benefit for the business here in the country. Long story short, post-digitalization implementation, we have now been able to go from 77 variants of the product on 3 lines to 180 variants on 1 line. We have been able to reduce the cycle times from 21 seconds to 9 seconds. We've been able to increase the number of quality checks from 22 quality checks to 68 quality checks. We have been able to, therefore, expand our offerings here in the country, but also are now able to export because of the high quality and the broader band that we are now able to deliver. And I think this is really the proof of what digitalization can do, not only for large companies, but also really for small and medium enterprises. This is not really only for the large companies. Digitalization will bring in a huge amount of benefit for the millions of small and medium enterprises that we have here in the country. Today, Siemens has over 100 used cases, actually practical cases, in multiple verticals, market segments here in the country, where we have really demonstrated true value for our customers. We are working with over 150 customers on trying to resolve issues that are most important to them. We have over 4,000 data analysts, scientists, and engineers working on this here in the country. So the resource and the commitment that Siemens has to the story of digitalization is immense. Today we celebrate the 2nd edition of what is slowly becoming a brand in the country of the Innovation Day, where we will showcase all these technologies, showcase some of these used cases to you, and really try and have, with the benefit of experts that you will hear in the first half, really explaining what the impact of digitalization, artificial intelligence, and IoT can really bring to all of you and your respective areas of influence. So please use the day today to ask questions, to go out and see what we are doing, to interact with our people, and really try and see how these ideas can really make a benefit for you. I'm delighted that today we have got Dr. Roland Busch here with us. Dr. Busch is a member of the Managing Board of Siemens AG, also the Chief Technology Officer of the company, and really an authority on digitalization. And I believe that we will benefit greatly by really understanding the depth that digitalization can actually give to the environments that we have over here. Dr. Busch, thank you very much for coming. Over to you.
Yeah, warm welcome from my side. Dear customers and partners, dear Siemens Limited board members, Steve Parek, our chairman in particular, dear colleagues from Siemens. I will talk about innovation and how we are taking innovation into strategic advantages. And I will focus very much on digitalization, obviously. But let me, before I talk about this one, for those who are electrical engineers, mechanical engineers, be assured that a train can be as digital as it wants. We still have to have a frame and seats to ride it. So that's a good news. So your jobs will not go obsolete. On the other side, all the parts we are talking about, the things, if you talk about the Internet of Things, will change. More of them, we have much more sensors, actuators, it will be more intelligent. We talk about edge devices, so that means there goes more processing power and storage into the edge, and this will change the way how we are doing our things, our trains, our devices in the future too, or our turbines. Well, the first question comes up, what does it take to create success in the digital transformation age? And now I can throw a lot of buzzwords at you. You have to connect, 5G is up, digital twin, very important, data analytics, the cloud plays a role, cybersecurity, very important, nobody lets you in and digitalize without having a cybersecurity, the storage capacity and processing power has to be there. Co-creation will be a very important role, because we are also need to learn what our customers know about the domain know-how we are bringing together. And there's one particular element on that chart which I would like to highlight, which makes really a big, big difference. It is on 9 o'clock. It's the new business models. There are so many changes, and the exponential development of our markets comes due to the change of business models. Think about Uber, Airbnb, any other kind of ways we are doing business. And this makes really the whole thing changing. And in the digital age, it's all about speed and scale. You know that, the winner takes it all. If you have software, each incremental sale of software falls all the way through your bottom line. You can invest more in R&D. So scale is important. And it's particularly important if you run a platform. And I would like to talk to you about our platform. We call it Siemens IoT platform at scale, of course. And before I do that, it's getting a little bit more technical, maybe a little bit more complicated. I'll give you a very simple example, which maybe everybody of you knows, because you're using that maybe on a daily basis. Actually, I do. Let's talk about the users of any kind of logistics platform, purchase platform like Amazon. When you go there and you order a piece of product, you open your window, you search, you find the right product at the right price, you order it, and it comes to you in a day, maybe 2 or 3 days. Very simple, all customer-oriented, very focused. And this is the reason why it has scale. Behind the screen, there's a big universe working for you. I don't know whether you recognize it, but I give you an idea what is it about. First and foremost, there are more than 200 million others joining you on that platform. You can choose from 350 million products on that platform. There are 110 world-class distribution centers working for you. In those centers, these are really world-class, they are working more than 100,000 robots, which are making sure that the whole logistics stream is extremely fast. Some of the best AI experts are working for you, having the right algorithms to propose to you what's the right product. The largest data centers are working for you, because this is where all the data sits and which we have to in order to work all the AI algorithms and really make sure that all the products come at the right time. So what I want to say is a platform is not only about technology, it is about ecosystem and a lot of knowledge about the customer behavior, buying behavior, and how we translate this into the industry. I would like to introduce to you on the next slides. There's one more thing which you can learn from these kind of customers. It is about customer focus, customer orientation. There's no pickup of any platform if you do not create customer value, so we have to put customer value in the middle of our picture. Is it internal, external? Why put I internal as well? Because Siemens is so big, we are active in 200 countries in the world. Deploying our own technology, our own platform to our own sites is of essence, obviously. So what does customer value look like? In our case, it is about time to market, productivity, efficiency, uptime of the assets, you name it. This is so important that we have a clear understanding what drives the customer and what's the customer value. The next thing is, what we can do is we can deploy our platform across all the verticals which we're serving, and they are quite a bit. We are covering anything from energy to healthcare, the mobility sector, the consumption, building technology, the industry, the whole industry space. So our technology cuts across all our customer verticals in similar ways. And then I would like to show you that the platform is not just about technology. You will see that in the middle. In the middle is the technology stack, which we are providing to our customers. On the left side, you see all the competencies which we have in the company, which are rolling to that platform. On the right side, you will see how our ecosystems looks like, how our partners are joining us in that platform. This combination makes this platform so valuable. And let me start, first and foremost, if a customer says, I would like to execute my digital strategy, question is, sometimes a customer already has an experience on one line, and then the question is, how do I roll it out over my, 10 lines and 5 or 10 manufacturing sites all around the world? So you start with IoT consulting. You consult what the customer is supposed to do. You make some prototyping, co-creation. You find out what's the particular need of a customer. Very often it's brownfield. Every customer is different. And then, of course, you have to have an integration plan, how to set it up. In that case, we have an IoT unit, our own Siemens IoT unit, which has a very, very strong foothold here in India. And on the left side, you see what are the competencies rolling into it. Customer access. We talking to our customers for many, many years. We are in this space for more than 170 years. We do have domain know-how. We know how to build trains, how to run an automation in a manufacturing site, how to run a turbine. It's very important. We have a digital twin, and we are building, as we speak, more and more digital twins, which helps us very much in simulating what we want to do. And on the other side, we have partners like Accenture, Tata Services, Atos, and you name it. These partners, they do have more and more expertise on working on our platform and bring also this integration capability. So we're working together in a kind of an ecosystem. Next thing is you need applications. And applications means really industrial software solutions. It's end-to-end. It's not just an app which you download and you don't like it and you throw it away, because we are working really on a running environment. So we must not fail. Siemens has got a huge PLM suite. Siemens is amongst the 10 largest software companies in the world. We invested more than 10 billion over the last 10 years. And this is the most comprehensive industrial software suite which you can get. We can simulate almost everything from mechanics, fluids, heat dissipation, mechanics, even electronics and software. And then we have our MindSphere application centers. These are the places, and I will talk about that a little bit later. These are the places where we are creating applications. We are bringing domain know-how together with AI experts, in some cases with our customers, and co-create and create applications. We have more than 500 of these applications which can be chosen from our customers as we speak. We need AI competence, machine learning. We have close to 1,000 AI experts and data analysts within our company. And of course, domain know-how, again. Domain know-how, that's what makes us different from any kind of IT supplier of a platform, because we do know what our customers are really concerned about when it comes down to the down-to-earth domain know-how. On the right side, very important, third-party applications. Our platform is open northbound. We provide so-called APIs. So every kind of software developer, can develop applications, and we add that to our so-called app store. And on the other side, we are working together with customers, creating together applications which are of use for them. The next layer, the whole thing has to run obviously on the cloud. or on-premise. I mean, some customers say, I don't want to give my data to the cloud, it has to run on-premise. The trend is hybrid. Some data you say, I want to have on my own. Some data you might push to the cloud. And here we have MindSphere, our industrial hardened open operating system. It's open northbound, as I said. You can have any kind of developer working on it. It's open southbound because we do have access to many, many different clouds and the most important ones. It is industry hardened. It is easy to deploy. It has a high level of cybersecurity embedded, and it comes with a high level of connectivity at the same time. Again, a lot of competence runs into that platform. It's about the way how we are architecturing it, the cloud competence, cloud development. We do understand the edge because it connects southbound to the devices. And we are sitting on the most prominent cloud platforms in the world. We do have a release on Amazon, on Azure, on Alibaba, and Azure on Stack will be our on-premise solution. So therefore, you can choose whatever cloud you want and deploy our MindSphere operating system on top of it, which then also, and this is the next level, connects southbound to the things. Connectivity is of essence. We have to connect, obviously, in brownfield environments, so we have to connect any kind of devices. Connectivity is extremely complex because we have to speak so many different languages. A building has a different protocol than an industry, than a gas turbine, than a healthcare scanner, or a train. The next thing is, what you want is, if you deploy our platform to your environment, you want to have that up and running, not only for 3 years, that's the time with which you're eventually exchanging your mobile phone, it has to run for 10 or even 20 years. So you have to make also in 10 years a patch, a software cybersecurity patch to your edge devices and make sure that the whole thing works. Maybe the processing power is increasing and you have to have a higher bandwidth connectivity. 5G is coming in. So you want to make that happen and connect your world to either our things, our Internet of Things, which is PLCs, MLCs, sensors, actuators, or to third parties, so Siemens or third-party devices. We are connecting everything, regardless whether it's a Siemens device or a Siemens thing or it's somebody from the outside world. And here again, a lot of competence are rolling in. All of our devices which we are shipping, they do have embedded a piece of a software, RTOS, and kind of a small operating system, also Linux-based, depends, which makes it very, very easy to connect to this platform. You can choose connecting it or not, but if you want, it's very easy. But we can also connect the other things. Why? Because we are working here again in our ecosystem. We're working on standardization. OPCOA is one of these buzzwords. Industry 4.0, we are engaging with many, many customers. We have our MindSphere world where there are a lot of customers are joining us, and all of them are supporting in standardizing this connectivity and the protocols. Actually, there's one thing missing, actually two. One is the most important element. The whole thing has to be designed on a very, very high level of cybersecurity, industrial level of cybersecurity. It starts with the architecture, so that the whole architecture is correct, and it ends with the devices. We are working with our suppliers in our charter of trust for cybersecurity that the supply base is already compliant with all the requirements which are necessary in order to make this platform cyber secure. This is a race, a constant race, and we are investing a lot of money to make this cyber secure. If time allows, I'll give you one example from our signaling system, which is mind-blowing in terms of how in a very, very high secure level you can deploy this platform. The last thing which I would like to highlight, and that's maybe something which we have to learn too, is the user interface. Remember, we are giving access to the management, to decision makers, a huge amount of data, extremely complex to find out what's happening in that space, and to make that easy to use, to make a very simple user interface so you can deal with all the data. That's one of the challenging tasks which we have, and we're working on this one too. What I'm going to now do in the next 15 minutes, I give you examples. How would this platform work together on concrete examples which are creating value to our customers? And let me start with, it's not working. Let me start with I think that's the user interface. And here I picked one example which we are very proud of. And it's not only the user interface, which is really cool, and you can see that in our exhibition there too, but it's also about the way how this platform can run also a city. We call it the operating system of a city. And actually, it's not really a city, but it's like a city. It's Expo 2020. Expo 2020 will run on MindSphere. We will control the security element, the lighting, the heating, the aggregation or the watering of the plants in our MindSphere application center, where we have many, many, many different applications running on it and run the whole ecosystem there. The next one is how the PLM suite, a digital twin, comes together for a very, very specific customer use case. And here I would like to show you one, which is the story about Mr. Brain. He's a US Marine who lost his leg in Afghanistan. And let's hear what he can say about using our Siemens PLM software.
I was shot in Afghanistan in 2012. I've always been an active person. I'm not gonna let it hold me back. I have a prosthetic foot. It allows me to be very active, but it's a bit heavy. There was a student interested in doing some kind of biomedical engineering project. Well, maybe she could redesign a lighter, more versatile foot.
We took the whole foot apart and we had crazy ideas. The goal would be to knock off 40% of the original weight. Siemens software lets me design and test the foot before we ever actually build it. This has taken almost a year to the day.
It does feel a lot lighter. Having a lighter foot is going to open up possibilities that would not have been there before. You know, the more kids that learn this stuff at earlier ages, they can go on to create new and better things that we're not even dreaming of right now. It's amazing.
Thank you. For those of you who are running, you can imagine what 40% less weight on your foot means. Well, another example on MindSphere, on our MindSphere platform, here again, I would like to highlight that we are working with the most prominent and the largest cloud services in the world. We released in January 2018 our MindSphere on AWS, followed by in January 2019 on Azure. And we also have a release on Alibaba Cloud. It's since April, it's up and running. Focus is obviously on China. And the next version will MindSphere on Azure Stack, which is then an on-premise solution, which our customers are also waiting for in order to run it in a hybrid. Next example, talking about MindSphere and MindSphere application centers. I was sharing with you the idea of bringing AI experts together with domain know-how. The key here is focus. What we want to do is we want to have MindSphere application centers which are working on one particular vertical, on one particular market. So they have the same kind of view in mind as our customers. And what we have meanwhile, we have 20 different application centers. I will share with you what kind of verticals these 20 application centers are working on. In 70 locations with more than 1,000 engineers, AI experts, and domain know experts all around the globe, also in India. And they're working on 20 different verticals. These are the verticals which you see here. I think they're a little bit cut. It comes from mobility, oil and gas, chemicals, cities, machine tools, whatever you can think about. There's an application center where you can really address your needs, and these guys are working with domain know-how together with customers on finding solutions and writing applications. I'll give you some examples. What's the outcome? For example, one outcome we are very proud about is that VW decided to work with us on running with MindSphere applications for 120 locations to optimize their plans, to run productivity with their suppliers, machine tool suppliers on the assembly line in order to drive productivity for VW. The next one is Hella. Hella is a machine tool manufacturer. And here I can give an example, what does it mean to change the business model? We are working with Hella and we are equipping their machines, connecting them, running them via MindSphere, give all the data in the cloud. And now they have a very good understanding what's happened in the machine centrally, even if they don't have their hands on it. So they run that and they have such a good understanding that they're now changing from selling a machine tool to selling machine tool hours for their clients. This is a completely different business model. It makes a big, big change in the market, and they are leading the pack. They can take a lot of advantage out of it. This goes only if you have a clear understanding what's happened in your machine at every point in time. Otherwise, this model will not work. The next one is about AI expertise. On 630 data centers in the world, we are running, with our application, we are running and optimizing data centers. And what we can do is we can optimize it and run it with 40% lower energy consumption. We do that in looking into all these devices. Something like 20 to 30% of these blades which you have in these data centers are anyhow not running because they're outdated, they will be replaced. But there's also the way how you can distribute your cooling according to the need of different processors allows us to do that. It requires a massive amount of data, and this is the advantage, talking about scale, since we run it on 600 data centers already in the world, we have such a rich database, so we can really optimize it and drive it to the next level. The next one is about rail and in the rail sector. We can achieve fewer delays and higher availability. One of the coolest applications I found within Siemens is that if we are equipping our trains or any other train with our system, we run analysis, in particular on doors, on gearboxes. This is where the biggest headaches come from, the operators. We can predict with a lead time of something like 10 days which door on a train is going to fail and why. So this allows each operator to pull the train aside, order the spare part even in advance, repair it and bring it up to the metro line again. We are running our high-speed trains between Moscow and St. Petersburg with 99.95% reliability thanks to our system which constantly monitors our trains. And the next one, again, AI and deep learning at work is on gas turbines. Gas turbine has 1,500 sensors. And it's kind of an art, you need a good engineer, to run it exactly at the right point. That means you have a required power rating, you have the NOx level which should be below a certain threshold, you don't want to burn your blades too fast. So that means you really have to optimize it depending on the environment conditions, always to the right level. We thought, why don't we try it with an algorithm? So this would be the so-called autonomous gas turbine. You don't drive it with an engineer, you drive it on its own. And we did that, and very interesting, when we took our hands off and let the software run, the software was trained, by the way, in the cloud. So it was trained and then downloaded to the machine, and then we took our hands off. It was very interesting. At the beginning, the turbine was running in a very odd way. We checked for different parameters, and after a short while, it was centered around the optimum of the parameters, running with 15 to 20% lower NOx level. We are training, as we speak, the next level, the better level of software, and whenever we are ready, we can download it again. This is one good example which also explains to me that this is not just an app you're loading down. It takes 9 months for a turbine because these are special requirements for special environments, and you cannot just try it out. If that fails, this is our sometimes 300 megawatt animals, you cannot run them in an uncontrolled manner. So we have to be very, very damn sure that the whole thing is working. Next example, talking about digital twin and domain know-how, how important it is that this comes together. And this is for me one of the very good examples where I can explain to you what is the difference between running analytics with AI experts and having analytics, including domain know-how in a digital twin. What you see, and you can buy a lot of solutions in the market, And you see that on the left side, there's a little red dot on this motor, which is a sensor. You plug it there, and it measures temperature, vibration, speed. Ours measures magnetic flux too. And then you can analyze the data, and you find anomalies. This is a lot of companies can do, except I would say our sensors are a little bit better, they measure a little bit more, but you will find these anomalies. And then you say, okay, something is going wrong here, you have to watch your motor. On the right side, since we have the digital twin of this motor, we can deduct from this temperature measure, and this is a point measure, we can deduct how the heat looks like within this motor, how the heat distribution looks like, and we can calculate what is the motor status in terms of torque and wear and you name it. So this is only possible if you combine the signals on the left side with a digital twin and the know-how, and you simulate what's happening in this motor based on a very limited amount of data which you have. This gives you much, much higher precision on what happens in the motor, when does it fail, how does it fail, and what's the problem. So this is a kind of a level of domain know-how which we do bring to our customers together with our digital twin. And one last example, this is now about the edge. So the edge means that all the devices which we are sitting on the shop floor are getting more and more intelligent. And in doing that, in making them more intelligent, you can lift your productivity to another level. How does that go? What you see on the right side, you see a controller. It sits on a shop floor, and it creates data, and these data, normally they go somewhere. I mean, you don't store them. We collect them and bring them to the cloud. We are analyzing the data and finding out, and this is not only one, this is a bunch of controllers sitting there and how they're working together. And we are developing in the cloud algorithms which make this whole combination of controllers sitting on your shop floor better. And then you have an edge device. It's a high power processing device, this industrial edge, which can take these applications, and you download these applications, again, trained in the cloud, you download them to this edge, and then the edge takes control of optimizing how these controllers are working. It sits closer, it can work on real time, so to speak, and optimize the plant. So you're optimizing in the cloud, you train your algorithm, and you bring them down and let it run. And you can deploy that out of the cloud to as many edge devices as you have at any point in time. If it doesn't work, pull it back, take the former version and run it again. So it's a very safe mode. This is, by the way, the power of cloud. Cloud is not only that you're storing your data somewhere, it's about how you develop. It's much faster, it's much faster development cycles. You put your software in so-called containers and deploy them in many, many different devices at the same time, and you can increase the way of speed with which you're iterating your software development much, much faster. We did that for Amberg, our Industry 4.0 electronic manufacturing plant, and this plant has a savings of 200,000 per annum in just optimizing the way how I described it to you. Well, with that, I wanted to make one highlight, which I'm very proud about. It's about cybersecurity. We won one of the largest order in our signaling systems business, which is Norway. Norway wants to go from, I'm always saying it's like from a dial telephone to voice over IP in one step. That means the whole Norway rail system will be run out of the cloud. It comes from 11,000 signals down to 0 because we don't need them anymore. More than 300 interlocking systems. We will compile it to one in the cloud. Actually, it will be a redundant one, but it's basically one. One data center, and we can avoid a lot of cabling, obviously, because we are just combining all the point machines, we combine them on one ring. This was only possible to win it because we could make sure to our customer that this highest security level system runs on a highest security cybersecurity system. I'll give you one example. We developed a so-called communication diode, which is a piece, which is exactly what it is, what it says. It's a piece of a hardware which allows data running only in one direction. it's galvanically discoupled from running in the other direction. So you can hack as much as you want. You will never get access if we don't want you to. So these kind of devices make a big difference and makes the system, these systems are typical still 3-level systems, highly security systems. We make it secure. I do believe that this is one of the biggest innovations in signaling which we have seen over the last 20 to 30 years. With that, let me conclude that what I've shown to you is a platform which is already at scale. We have so many examples. I talked about 500 different applications, and we're getting more and more as we speak. There are more than 1,000 AI experts and data analysts working for you. We have a huge ecosystem. This ecosystem is increasing as we speak. We have integration companies. They are training their experts on our technology platform, on MindSphere and the whole technology stack. We have an increasing amount of digital twins because we provide the software. We are talking about, we use that on our own. So we have so many examples. The system is ready, and we are more than happy to work with you, customers, on creating more and more applications and more customer value for you. Thank you for your attention.
Thank you very much, Dr. Busch, for your incredible insights on what digitalization can do for business and impact human lives. That was a very interesting story there. We open the floor for questions now to all of you for Dr. Busch.
You can run, this is a particular protocol. This was running for signaling, but we use it also for industry. So that means you can use it on different applications, different protocols. The basic idea is that we have a kind of a galvanic disconnection. So, and we are using that also, for example, for process industries, which are also very, very critical. You can imagine in a big petrochemical plant, you don't want to have any problem there. So you can deploy that also for other applications aside of signaling. Absolutely.
When we think of any control system, I always visualize it as I'm reading something first, and then I'm going to give some control whenever necessary. So if the protocol itself and the device itself is designed in a way that it will only send information in one direction, how do we control it?
So there are two ways. In some cases, you want to read and write. In that case, obviously you have to have you have to open the connection in order to influence the system. This is a use case which we have in many instances in manufacturing, for example. There are use cases where you just want to read and understand what's happening in your system and not allowing to write. This is you have to really separate these two different applications. There are many, many applications where we can see that reading is good enough because you would then influence and take your consequences how you optimize the systems in another way other than out of the cloud remotely, so to speak. It's a choice. But you can't have both. No? I mean, if you really want to make it cyber secure, absolutely, and be sure that nobody can really do every odd things, we have a solution for that. And by the way, there's another element in it, which I didn't highlight, which is also interesting for some experts. Normally, when you run these high-level SIL level 3 systems, what you have to do is, in order to, before you release an action, you have to run it through two different processors, hardware, with two different algorithms, the same task, and if the result is the same, then you can act. This is a kind of a SIL level 3 cyber security level. And this was good as long as you had single core processors. But now we have multi-core processors. And then actually the solution was take 2 multi-core processors, so double your investment because you cannot run that differently. Our engineers, they made the same level of security on a multi-core processor and run that on the same processor. Saves a lot of money, but with the same level of security. So we have this solution too.
Thank you.
Yeah, good morning, sir. My name is
Here we go.
I am Ashwani from Reliance Mutual Fund. We are investors in your company in India, the listed company. My question is, what is the retrofit opportunity which you have addressed, let's say, using these solutions in the Western world? And second, how much capacity does it release? Because as you pointed out, you can make multiple products, you can make your lines doing more number of products, more complexity. So how much capacity does it release? And lastly, what kind of opportunity do you see in India?
Okay. What was the first one again?
About the retrofit opportunity.
Retrofit. So, yeah, this is actually, retrofit is maybe the 95% of the use cases. Because what you have in most cases with a brownfield application, and you have customers saying, okay, let me start connecting my devices, getting information, and then roll it out. So therefore, we do have a Mind Connect, a box which is called Mind Connect, which you can deploy, which makes it very easy. If you do not have the connectivity, we have also some solutions we are working on where we are taking, if you have a brownfield environment with automated, semi-automated, and non-automated at all, we can also have a solution for that. We are encapsulating any kind of non-automated parts of an assembly line, for example, and create a kind of a black box out of it, which gives you the necessary amount of data which you need. So there are many, many different ways, and this is a use case which we are taking care of, and I think it's a very important one, firstly. Secondly, it's a very generic question, I guess. What we can show is that we have productivity increase of some 20%, 30%. It depends also whether or not you're also starting with your, in manufacturing space, whether you're starting also with a digital design of your products. Because if you do that, then you have the so-called digital twin of your product. We would create a digital twin also in brownfield of your site. And then once you optimize it, you build it, and then you can all collect the data and bring this data, if you see something is going wrong, back to your design and optimize it. If you do that, your cycle time can shorten substantially, not only the availability of your assets, it can shorten substantially. And generally, if you want to get a number from my side, I would say it's something between whatever 10 and 50%, which is what you can achieve, depending on the level of automation what you have and what you want to do. For India, it's important. I mean, Sunil talked about it. I do not believe that you can manage this challenge of driving such a high productivity in not using and deploying any kind of modern technologies. We see that from customers who are using, let's say, the whole technology, from the PLM to the simulation of your plant, to, let's say, gathering all the data in the real-time environment with MindSphere. You cannot drive this productivity without deploying this kind of modern technologies and connecting your devices. Does it have an impact? This is another question. Does it have an impact on employment? Actually, I don't believe so, because this is the only way how you can drive productivity. It does have an impact because you have different skill sets you need. So education and training of your people, is it in engineering, the white collar, blue collar worker, is of essence. So that's something what I would highlight again and again. You will not be able to deploy these technologies if you're not bringing your people on a different training level. But I do believe that the productivity, the necessary productivity which you have to have in India will be enabled in using these technologies.
So how do you price these products? Because different buyers have different purchasing capacities. So companies in India would have a different purchasing capacities.
Yes.
But let's say when you price these products, does it only help you retain or increase marginal market share, or is it a very transformational thing over a period of time?
It's the later one. I mean, what we are pricing, we have different prices. I introduced to you a software stack or a complete technology stack, which is software, which you have MindSphere, which has a certain price. It's pay as you use model. We have other technologies, our edge devices, connectivity and the like. So it really depends on which kind of part you're calling. You can also work together with the ecosystem, so blend in our technology stack with partners. And we do have also consulting, which is a team which is helping you, really giving you an idea, where do you start, where do you want to be, and what's the next steps. This is another separate business, so to speak, which customers are paying for. If I got your question right, this whole thing is really transforming also our business, because we are coming from a company who was for 170 years basically selling products. Some of these products are already very much loaded with software, embedded software, But we are now going more in the direction of selling value to customers. In some cases, for example, we are selling the availability of trains. Of course, we sold a train, but then after all, we are selling the availability of trains, the uptime. We have a bonus-malus kind of situation, and this makes a big difference for customers too. So it's for us also a transformation, and we are changing our business models as well. Thanks for your questions.
Thank you very much.
Thank you. The gentleman there.
Hello, Dr. Busch. I'm Balu from TCS. See, I think I understood the technology, but when it comes to adoption, I still see the data is often split across multiple enterprises and different organizations. And for all of this to come together, this is still an adoption challenge. So
Yes.
how do you think organizations are maturing? You know, you have seen
Yes.
different parts. So what do you think organizations should do to come, stop this data holding and hoarding and being able to,
I hope I understood your question because it's an echo here. This was the question about having your data sitting on different enterprises and different. What we are providing is a kind of a data lake, which is collecting structured, unstructured data wherever they are coming from, and bring them together in a way that you can take use out of it. I have to say that this also requires a certain kind of structure of your data. I mean, you can push in as much as you want, and we can do something out of it, but the better the data are structured, the better, obviously, you can work with it. So, therefore, we're providing solutions. We do that, for example, for Dubai. In Dubai, we have a data lake, and you can imagine that they're dumping so many different data from so many different systems, also system suppliers, which are working on this expo, and we are using a data lake in order to get all the data together and analyze them. Here maybe on a side mark, which maybe Michael will talk about it later, is the next thing on AI is called knowledge graphs. What you're going to do is you take your data and actually you create a semantic database. That means you take a data and you put some attributes around each data which are linking the data together. This is how your brain works. So, I mean, if you leave the room later on, you remember maybe that Roland Busch was talking to you, but you will also then remember there's a lot of light here and big screens and whatever, and a big team of people sitting there. And later on, when you start remembering, you're connecting the dots, and this is how your brain works. This is exactly what we are now also simulating or creating into our systems. I'll give you one idea, which I found completely cool. When our mobility colleagues or our energy colleagues, when they go for a power plant or for a turnkey mobility system, and we get tons and tons of data. What we're going to do is, with a semantic database, that we run this data into our database and get a first draft of an engineering of a power plant or for a turnkey system out of the box, out of the computer. And then the engineer can start on a much, much higher level working on that one and fine-tune it. You can imagine how much productivity that drives and how much learning you can get into it, not repeating all the mistakes you did in the past. So that's something we're working on, and it goes in the direction what you're thinking of, I guess. Thanks.
The gentleman there.
The SIL 3 and SIL 4 level systems. So you mentioned that Siemens engineer had come out with on the single processor, they can run two separate things. But what I believe is that one of the necessary mandatory aspect of SIL 3 or SIL 4, depending on the application, is to have it physically separate.
Yes.
To add to the safety level.
Yes.
So I'm not sure if that is getting compromised. So that was my first question. Maybe you can answer that
Very
first.
quick answer. It doesn't. This is the cool thing about it. Even though it runs on a multi-core processor, it doesn't. If you go any deeper, I think I would ask you to guide you to your mobility booth out there. But this was my question too. That isn't it a compromise because it was before completely separated, and it isn't. And that's so to speak. I think that's also already homologated by the German authorities from the Eisenbahnbundesamt. So you don't no compromise on this.
The reason I say is because we do have many customers from Germany, and they have mandatorily said that we need to have physical. So that's where I raised this question.
Yep. This solution does the trick.
So that was the question one. The second question Like similar to what you said, GE also at some point came out with the predicts, and they also from a product wanted to go into the software and the services. And what the Siemens today is doing also possibly is in the same line. How do you think the MindSphere is different from the predicts of whatever the GE had in terms of? And secondly, there is always a conflict of interest because Siemens is also into the product. At the same time, you are selling this MindSphere related services whom your competitor may also want. How do you address this problem?
Yeah, thanks for that question. Very good. First and foremost, even if you're jumping on MindSphere, this is a layer in a technology stack. In principle, you can take MindSphere out and run native on the cloud. Using AWS cloud services directly, run it native, run the applications, yours, ours. The whole thing still works. It makes it much, much easier for you to do that because let's assume now you want to run on different clouds. You don't have to redevelop all your software again and again. You can take your application once it sits on MindSphere and run it on different clouds. It provides you also with a kind of enhanced level of services. I was talking about the data structure, which is embedded, for example, for building technology. It's embedded in our platform. So you have a lot of advantages. But actually you can take it out. I mean, talking about competitors' products, they basically do similar things. The details make the difference. The details in terms of how is it cybersecurity, how much domain know-how runs into your platform, how does your connectivity look like, how many protocols does your platform speak, and we speak many protocols across everything. So if a customer says, I want to optimize my manufacturing line, and then he comes to the idea, oh, I have buildings too. I mean, you're sitting already on a platform which can take care for your manufacturing, for your building, for your grid. So that's really a tremendous advantage. Last thing on this one. What I try to say is, on your point is, you can also run this whole stack, take the lower left part of our Siemens products out, and take third-party products in, and it still runs. So this is the beauty about it, that you can use the upper part of the stack without Siemens products too. Obviously, we like you to use Siemens products, but it's not necessary. So, and you're not bound. You can choose freely from whatever products you want to have. It will still work. So at the end of the day, the last message I want to make here is think about this whole thing not from a piece by piece, but it's the whole ecosystem which comes together. So you can take pieces out, you can use third-party applications with MindSphere, without MindSphere, but this whole thing working together for you is, I think, the big power. And there are, again, more than 70 MindSphere application centers which are working on different kind of applications. All of them are paying into the same app store, which you can use from. So it's getting more and more powerful, the more it scales, and it scales already.
Good morning.
Good morning.
Sudhir Pawar from Reliance Industries. I want to give some feedback or some of the challenges from an industrial product customer. So what I observed, despite many companies are talking about digitalization, but then I find that year on year, your price list for the product is increasing and increasing. That is first point. Second point is that the rate of obsolescence has increased. So by the time we install one product, the manufacturer comes out with another version, and then there is a problem for the customer. So how the digitalization is going to work on this?
Good. What was the first one?
There's constant price increase and digitalization.
Okay.
By the time you implement something, something new is already coming.
Okay. So I cannot charge too much on the constant price increase, because actually what my people tell me always that we have a price decline. But maybe there's a misunderstanding. We have to double check. So normally, serious. Normally, what you see is on the one side, if you talk about the products, it is a price decline. If not, you're going on a next higher level of higher functionality, obviously. Then, but that is not apple to apple. But in principle, we have a price decline. And the other point is, if you use, for example, MindSphere, you can also choose a pay-as-you-use model. So that means the more you use it and you get your benefits, then you pay more. And if not, then you have different kind of levels, so to speak. how much you can pay, so you can tune that very much so. And the other one was about the newest releases. This is also very important to us. If you choose our platform, and you might have an experience with IT companies, for a certain point of time they run their platform and then they stop their release, they don't maintain it anymore, and then you go for a next version and you have a real problem. We cannot do that. So we will always be backward compatible. That means whatever new release comes, it works with your older versions. And there will be new releases. I mean, don't forget, and this is what I'm telling our people also, digitalization has another element. It shortens your development time. And this is roughly by a factor of maybe 3 to 4. That means you have a much, much higher speed of new innovations coming in, which is good, as long as they are backward compatible. And this is what makes an industrial platform different from an IT platform, that we have to make that. This is how we make our business all the time, and we keep that also going in this IT space. And this is another advantage which I believe customers can take from. I don't know whether I really answered all your questions.
Okay, my questions were from the
Can you speak up a little bit? It's hard to hear. Can you?
My questions were from the industrial products, not from the platform. So
yeah.
The kind of products which Siemens sells or any leading manufacturer sells in the market. So by the time we install, the new product is being launched, and then the customer faces problem. So for like suppose you take VFDs, your drives, your motors, new series of motors are being launched, new types of industrial products are being launched. Anyway, it's okay. Thank you.
Gentleman behind. Yeah.
Hi, Roland. I'm Manish Singh from Johnson & Johnson. My question is two things. One is on the data lake part, which you talked. So I think probably it sits almost on the top of the technology stack, which you talked about. Are you saying it will be kind of an end of the road for conventional historian kind of thing, or are you saying that ultimately historians we can foresee moving into data lake in 2 to 3 years time frame? The second question, you talked about semantic database. In my industry, in pharmaceutical and consumer product good, we call it contextualized data.
Yes.
So, and we are like in J&J, this is one of the project which we are working with, and probably Siemens is one of the probable technology provider for that. So we are actually looking for an contextualized database, which we can host in a cloud.
Yeah.
And we can use edge devices for small time or near time storage, but push all the data into the cloud, say for more than 24 hours part. So where is Siemens? Because this is for the first time that I have heard of this, and we have been interacting with multiple Siemens entities worldwide. So where is Siemens on this as an as a product which is there in the market, or even it's there as a prototype?
So on the first one, I do not believe that the future of a digital landscape of a company is monolithic. I do believe that you have your historian database, you have a data lake, you're feeding the data lake from the historian, and it will coexist, so to speak. I don't know how the future will look like, whether you're merging then and you're consolidating these data lakes. By the way, these are also thoughts which we're giving to us as well as Siemens. You can imagine how many different data we have in our manufacturing sites and how to host them. And the point is, you will have a kind of a coexistence. The data lake is something where you really bring all the data into it from different systems. In the cloud environment, we have this massive amount of data with a very fast data access in order to really run your algorithms as fast as possible and use it that way. So my answer would be coexistence, but you have to make sure that you still get your data structure straight in your historical system or your ERP system. Otherwise, it will be more and more difficult. You can do it, but it would be much, much easier. On your second question is that we do have, so there's not a, I think the point is that each of these applications, if you talk about this contextual semantic database, you have to, it's not out of the box, because each application is different. I'm not quite sure whether you have already some from the chemical, pharmaceutical, chemical industry and the like available. I do think so. But we have to talk to the customer and build it with experts to build this database up as a frame. This is how we do it also for our applications, for example, for the power plants, for the trains. And this is a one-time effort, what you have to do, and then you can work on it. I'm not quite sure whether we have already a kind of a frame which we can use for your particular industry, but Michael May is here. If he can say much more, I would like to connect the both of you. Yeah. It would be very exciting to work on this one.
The second question which I have, I was expecting you to show, the future,
Yeah.
What you showed was where you are and what is the near future. So if you have a magic wand in your hand and, being in your position, you must be going through a lot of stress, of the technologies which are not cracking as fast as you would have liked it to. What is the one technology which you would like to get solved with your magic wand?
Actually, I'm awaiting this question and I'll give you a couple of them. What I would like to see is rollout of 5G technologies all over the place now. Deployed in the way how industry gonna use it, meaning you know this is a triangle. You can gear 5G for data volume, latency, reliability. And I want to have deployed and geared for latency, so lowest latency and highest reliability. We don't care too much about this bulk of data. B2C applications would. If we have that, and we have it deployed in over the place in our markets, I tell you, we can immediately change a lot. Second would be quantum computing. I would like to see quantum computing up and running, so that means we have much faster algorithms and running them on a higher speed, which brings another problem, because then the unfriendly hackers will also use quantum computing to penetrate our systems, which would be another turn in the whole system. And the last one is, if I would like to see this, what we talked about it, this contextual semantic databases, this technology, to be rolled out much faster, because I believe once that kicks in, that lifts the way how we are using data and how we can analyze data on a completely different level. But you need a much more solid base of data which you have, and this is it's about building it up, coming back to your question before. But once you have that, this is really the next level, which can you, and then you can use much less processing power and draw much more consequences out of it.
We have time just for one last question.
I'm from Reliance Industries Limited.
Here we go.
And we are currently talking to Siemens for asset management.
Yeah.
So we are looking for asset management of our electrical assets in Jamnagar refinery for 220 kV, 33 kV, 6.6 kV class equipments. So like you said, AWS, Azure, and Alibaba. In Reliance, we have our own Geo Cloud. And our asset data, we want to have only in our cloud. We don't want that data to go out. How Siemens can help in that?
Do you want to have it on your...
On our own cloud.
On premise?
Yeah.
That's what I said. We are working on this on-premise solution. Many customers have this demand, that they say, I don't want to go my data out. We talk about oil and gas industry. The holy grail is the data where they have their reservoirs and all that stuff. They will never ever move onto the cloud. So, and we have the same for you. So what we can do is, actually in many cases we don't even have to own the data. So if you own the data, run it on your server, we can deploy the technology, give you algorithms, and you run them. So that means they are trained obviously on other data which we have access to, but once you have a problem solved, for example yours on your asset management, on any kind of applications, grid applications like, then you can also use this trained algorithms, give it to you, and you use it on your own. So that means no need of transferring data. Actually, we do need data in order to train the algorithms, but we have many, many different cases. We love our customers who would share, at least share part of the data, so we can train the algorithm, and it's a benefit for many, many customers at the same time, but we don't have to. Give you one example, which is the most mind-blowing because it's less about competition. When I talked to the metro operator in Hong Kong, I mean, he was saying that, can you optimize my trains? And I said, yes, absolutely. And then his first question was, I have just, 500 trains, but you have maybe 5,000 you have access. Can I get access to all the learnings from your 5,000 trains which you're monitoring every day and deploy all the learnings on my trains? And I said, absolutely. And he was ready to share because he's not in competition with the Metro of Munich or Metro of New York because he runs the Metro in Hong Kong. So no competitive issue whatsoever, and customer ready to share. This is not always the case. In some cases you are very, very sensitive, but we are very mindful about this one and respect obviously the data privacy and data integrity if you want to have it.
Thank you very much, Dr. Busch. I know a lot of people have a lot of questions for you, but maybe during the day.
We'll be around.
Yeah, thank you so much.
Thank you.
Thank you very much.
You.
For India, topics like smart infrastructure for urban environments, Industry 4.0, artificial intelligence, digital twin, IoT, the startup ecosystem are really buzzwords and of prime importance. In our next section, we have subject matter experts on IoT, Next47 and artificial intelligence who will tell us how Siemens is making a difference to the industries that we work in and outside to human lives as well. Our first expert is Bettina Rotemann, Head of Marketing and Sales Support, Siemens IoT Services. Bettina will tell us how to maximize your business potential through IoT. Bettina.
Thank you, Ramya. Thank you so much. Ladies and gentlemen, Dr. Busch just ran us through the speed and scale of IoT, and that is exactly why the IoT Services Unit has been created just recently. We were born on 1st of April officially, so pretty new to this field, and we aggregated a lot of experts and elements out of the existing Siemens world to form one potential squad that really helps customers to drive their unique digital journey. And when I say unique, I really mean unique. It's like a fingerprint, right? So every of your businesses is unique, and every of your pain points might be similar to other pain points, but applied to your specific business, it is unique. And that is why you need experts that help you through this digital journey to really find out what IT could be for you. So we got a lot of questions about what are you doing? And we aggregated this beautiful picture that you see in the back. When I tried to explain it to my mom, I failed. So she was just like, what are you doing, kid? You know, like every day in work. And I said, Mom, it's pretty simple. Look, we have this OT world and we have this IT world, and we make it talk to each other. And then she was just like, what do you mean talking to each other? And I said, Mom, listen, your OT world is your fridge. And there is milk in the fridge. So what if you could adapt your fridge with a sensor, make it talk into your IT system, like the ERP system, in brackets Dad. So if you're running out of milk, the sensor would tell Dad to go and fetch some new milk. And she said, kid, listen, I would open the fridge, I would look into, I see the milk is running out, I will call Dad, and Dad is going to buy some new milk. And I said, Mom, this is cool. If you're in industry and if you have thousands of assets, but you do not have thousands of dads, so what are you going to do? So she said, well, okay, I get that, but then why does it really need to be IoT? What does it bring me? And then I said, listen, could be cities with less traffic but cleaner air. What if you bring your traffic, what if you equip your streets with sensors, and you can run through this like a little bit faster than being stuck in the morning 3 hours before you go to your job? It also could mean that if you redirect the traffic, the air pollution could go down. Not standing 3 hours with full consumption and energy and gas blowing in the air, that would be nice, wouldn't it? It also means healthcare with less waiting times and a better treatment. So what if you have a smart hospital? What if all your OTs, like the X-rays, like the MRTs, the CTs, would be equipped with sensors? And you come into the hospital, you know you have like several stages to go through, not piling up in front of the X-ray where already 20 people sitting, but directly going to the CT, which is empty. And also it means, like we talked about the contextual data, what if the CT would blow the pictures anonymized into the cloud, and the detection of whether that is a disease, whether that is cancer or not, could be so much easier because the machine learning tells you already, based on millions of pictures have been predicted before, that this is something that is dangerous or just not. It could also mean factories with less resource consumption. We are running really scarce on resources on this planet, so this can really make a difference if you have 10% savings or if you have 18% savings on your resource consumption in your factories, not consuming too much of these scarce resources that we have, but also the higher output. What if, as Dr. Busch pointed out, you have sensors on your machinery that tells you, hey, in 2 weeks' time, this is about to fail. So you do not need to rearrange and you do not have the spare parts right now, but you can plan the out times and reduce the failures of your machinery. Also, when it comes to agriculture, what kind of chemistry really is needed to make this stuff grow? It could be so much healthier if there are sensors in the soil that detect, no, this is already enough, not more energy, not more chemicals, it's going to be fine. We recently visited a customer that was measuring the soil with sticks in the ground and just like picking them up, looking at the sticks, whether that would be good or not. If you have sensors in the ground, it tells you exactly what the condition of your soil is. Less chemicals needed, a better outcome, and also it's more food. Even if there are scarce resources like water, and we all know that this planet has a problem with water consumption. So when you look at IoT, what is IoT really? It's an ocean full of opportunities, literally. There are so many things you could do, and when you look at it, the CAGR predicted for the next 3 years, if you really look into the conservative numbers, is double-digit. Actually, there are some analysts that say it's even higher, it's even double the number that you see here. And also it means there are new revenue streams. This is what Dr. Busch was pointing out. There are a lot of new business models ahead of us. What if you really digitalize your business? What if you come up with completely new stuff because sensors, digitalization, gives you an abundance of new opportunities you could tap into that some of the people do not even dare to dream about today. What is it in terms of differentiation? It's so much worth to differentiate against your competitor today. It also is so much worth if you have a good customer experience because then people and clients stay with you. They do not change for the competition. They know the value that you are bringing to their tables. And also in terms of optimization, we already heard that it's increased productivity, it's increased reliability of the assets that you have, it's enhanced efficiency and security and prediction of the assets that you're running and the business models that you have. So, if this is an ocean full of opportunities, why only 30% roughly are doing it right at the moment? So if I look at the room, this sector would do it, this sector not would do it. What is the reason for that? We recently conducted a survey with Harvard Business Review asking 750 C-level decision makers globally, what is your pulse about IoT? What are you dreaming about? What are your challenges? What are your pain points? And a lot of respondents said, yeah, there are a lot of obstacles in my way, and actually there are 2 reasons why IoT not is fully applied and deployed these days. The one is, there is an idea, but how would that idea give me value? How could I make a new revenue stream out of that? The problem is, sometimes it's not obvious. You know, detaching sensors to your assets and then having a reliable world, that's one thing. Coming up with completely new business models like we've seen in the Hella example, that's a different story. You really need to sit down, you really need to think through. Sometimes there is an abundance of opportunities you can tap into, which is the one use case that really makes the difference. which is the one use case that really drives the needle. So it takes a while, and that is why a lot of people say, I'm lacking good experts helping me to dive into these ocean of opportunities, to help me find out what really makes sense for me, as I said, because I'm so unique as the fingerprint is, and maybe the solution from the one end is not helping me on the other hand. The second one, and that goes out to all these CTOs of this world, is people working on critical infrastructures do not tend to like to work on that. So I've once worked for a national telecommunications provider, and we only had 3 deployments of the software per year. Why is that? It was so critical, and actually it really looked like the elephant balancing on this ball, because if you do something severely wrong, 33 million people in Germany would not be able to phone the next day. So if you want to make amendments to such a critical infrastructure, you really need to make sure there is value behind, and you really need to make sure that you know exactly what you're doing. So out of this poll that I recently did with the stuff is 74% of the C-level executives says that it is a real making difference to their world. So it will become a competitive differentiator. 70% say, I know I need to adopt to that. I really want to, but 46% say, how does that give me any sort of value? And even 45% say, I'd like to begin, I have some good ideas, I don't know why and where I need to begin. 40% says, I want somebody that tells me about IT, and at the same time, I want them to understand my industry. Because it makes a huge difference whether you apply a service in the energy sector with IoT than what you do in healthcare. It's a completely different world. So I don't need somebody from the energy sector when I'm in a healthcare to tell me what I need to do, because, you know, you've never been into my industry. And that is, you, clients, Siemens customers, want somebody that understands IoT and their respective industries. And they want somebody that stands with them from A to Z, from the beginning till the end. Because you can tell, when you work in critical infrastructures, when you work on this stuff, it can get tough. So this is where people really seek out for somebody that understands both industry and IoT. So showing you a little bit of how we do that as the IoT services unit and how we help customers to go through this. You see, we have a strategy that needs to be developed. But sometimes customers already have an idea and they want to step in straight away, and they want to move out of this POC purgatory. They are stuck in their POC, they don't know how to scale it up, they do not know how to put that into their IT legacy systems, which we know is a difficult thing to do. So what we always do is, you need to have a North Star. You need to have your why. Why are you doing that? So in this regards, having a proper digital strategy where you're aiming at is really key. What we then do most of the time is to really start small. We are not boiling the ocean. We take something that is of relevance to our customers, something where the biggest pain point is, or something where the most revenue maybe sits. So we start small. We take something, and then we ideate and prototype. And I will show you later on in an example what we did. So really starting small, working in a small and safe environment, and then scaling up. Next would be you connect and you adapt, and you look into how would you potentially integrate that into your legacy system. At a later point in view, you analyze, is that running straight? Is that really good? Is that delivering the value that I'm expecting it to do? And at a certain point, you say, yes, tick in the box, it's all good, I can operate the system. And we are ready to start the journey with you wherever you are right at the moment. Because as I said, some do not even have an idea, some have an idea, some already have a POC and want to scale. So what we do is we are capable of consulting you on any part of this journey. And Dr. Busch already pointed out, cybersecurity is something that is mandatory. You do not bring your critical assets into the cloud unprotected. You would never do that. You do not leave your house open. That is crystal clear. And at the same time, which most of the people forget, is you need to take your people on board. You know, you're implementing new technology, you're maybe rearranging your whole setup. Eventually, you're running different business models with different skills that need to be there. So don't forget to take your people on board, being it through trainings, transparency about where that should lead to. This is really mandatory for a sustainable digital transformation and not just a one-off that most of the people think. So let's have a look at one of our customers that approached us saying, hey, listen, I have an idea. I'm an electrical retailer, more or less, you know, I'm sending boxes. Good. He just found out that maybe in 5 years he does not even have a business anymore because there are so many copycats in the world that are sneaking behind him. So what is it that we then did? He had an idea. We sat with him in an ideation workshop together with our colleagues from MindSphere, and we looked into what is already there and what are the potential use cases we could tap into. So there is a methodology we apply, which is called the BISMO, the business model, and we run through different stages with the customer, really diving deeply into what is your now and where do you want to aim to and how do we bring you there. The next thing was we validated the proposition. So what we did is we looked into what are the customer personas. There's the one in the control and command center, which is one persona, but there's maybe another persona, the field worker, that needs to apply all these things, that need to run out after assets and need to be managed. So different personas, different needs, different skills. And we made sure that the different user journeys were consistent and were all running back on one system and one application serving different users and different personas. We went with the customer into rapid design prototypes. So we did these click dummies that you see, if I click here, then this is happening, and then this triggers the next event, etc. And we did some customer validations. It's always good if you go out and ask your direct customers, you like it? Is that bringing value to you? Before you really start designing stuff that in the end will fail because customers dislike it. So this is really important just to go out and test it with your customers. In phase 2, we said, okay, now we have an app. How does that fit into the market? Where is your competitive edge? Where is your unique selling point? What is your killer application that we need to bring up? Out of that and the meaning we derived from that, we created business models and a huge business case. So from buzzword to business case in a very, very short time frame, because that was only in 4 weeks' time. Technical concept is then something that is absolutely necessary to have because you're not implementing anything out of scratch. You really need to make sure that it fits to your future systems. And then we coded the app and installed it in a sandbox environment. Not in the critical infrastructure, which is huge, but in a very, very, very tall, small item that's similar to the mother legacy system. We tested it, and it was good. And now what we're doing, not yet started, but due to come, is we're going to code it for the MVP. We're going to deploy that into the mother IT legacy system. And we did that in only 2 months' time from the ideation to the point. So speed is possible with Siemens. That's a clear and strong voice. With that, I'm leaving you. Any questions? We see later, maybe in the hall. Thank you so much.
Thank you, Bettina. I would like now to call Dr. Michael May. He heads company core technology, data analytics, and AI to speak about industrial artificial intelligence and how we create impact for Siemens and for our customers as well. Dr. Michael May.
Hello, everybody. Welcome from my side, and thank you for inviting me to this wonderful place in Mumbai and giving me the opportunity to show you what Siemens is doing on artificial intelligence. Roland Busch already gave a good overview on the high-level picture, so in my talk I can maybe go at 1 or 2 places a little bit deeper into the details and about the technology. But before going deeper, let's have a look back on the company Siemens. So Siemens is a company, not exactly a startup, but a company which is around for many, many years. And it is a company which, during its long existence, all the time had to reinvent itself in terms of technology, coming up with the next wave of technology which hasn't been there, inventing it, adopting it, and bringing it forward. And many people, I think, in Siemens would say, now it's time to reinvent again. And this reinvention is around the topic of digitalization and across AI. And if I extend that line to the future, so if we meet again in 10 years, let's say, here in Mumbai, and look back at that line, what have been the technologies that have changed Siemens, then I think I will show you some candidates from my point of view that are candidates for adding to that line. Now, artificial intelligence, I think it's not just one important technology. It's a quite special technology. It has been selected as one of the 14 company core technologies on which Siemens technology future depends. And it's special in the sense that it's not only important in itself in the use cases, but also because it's enabling most of the other technologies we talk about. So if we take the future of automation, many people would say the future of automation, it's just artificial intelligence. So without AI, no future for automation. Or if you take autonomous robotics, so unthinkable without artificial intelligence. And even cybersecurity, it's something, so it becomes more and more complex, more and more types of attacks, more and more dynamic environment. So hard to think how you can manage that defending against attackers without intelligent method. So the importance of AI in itself, but also as an enabling technology for others. And I'm responsible for this topic, this company core technology, data analytics and AI, and trying to bring that in as many use cases as possible. Before showing some of the more advanced use cases in AI, I want to make the point that Siemens is active in this area, data analytics, machine learning, for many, many years. So if you go back, it's 30 years or even more that we're doing that. And already 20 years ago, or actually in 1995, so the first neural networks went online for quality monitoring in steel plants. So since then, we know there's a case for AI, and AI can do a lot of good business. The other use cases, Roland Busch has mentioned the predictive maintenance for the doors of trains, the energy analytics in Amberg, and we also use analytics for root cause analytics in the Large Hadron Collider from CERN in Switzerland, so one of the largest automation environments which exist in the world. Or we use it for smart cities, for example, the city of Aspan for asset performance management and energy management. Now, in the next stage, I will show you some more advanced cases where we use deep learning and other technologies. This one is for preventive maintenance for oil and gas. So in this case, it's anomaly detection for oil pumps based on deep learning-based methods. The difficulty here was that you have very, very little incidents for these pumps. So most of the time they run well, only very rarely you have some problems. So you have to learn a model more from the positive cases where nothing goes wrong, and then you have to infer what is an abnormal case, and that is what we have doing here in a co-creation project with an end customer in Germany. And there's a nice story about that. So we came up with a model, we came up with a prediction, this pump is going to fail, and then our customer, he would not want to believe us. So he said, no, I know that very well, everything is running well. So our AI experts, he went to vacation. When he came back, he phoned the customer, and the customer was saying, oh, you were right. So now we found out the pump is broken, so your model was right. And after that, of course, he was more than willing to invest in AI. So these are the kind of proof points you need, at least for some customers, to convince the value about AI. Now, going one level further in terms of autonomy. So this is a very nice example from Siemens where we go into the autonomous driving business. This one is about autonomous driving trams. It's in complexity somewhere in between, for example, a metro line, which is basically solved, so this is not an AI problem, and autonomous driving in a fully unconstrained environment, which is still a couple of years away. Trams, they are somewhere in between, so you have people crossing the street, cars crossing the street, so it's a complex open environment, but on the other hand, you are rail bound, so it's not that a tram can go anywhere. In this example, the colleague from Mobility in Germany, they made a first demonstrator of an autonomous driving tram in the city of Potsdam. It was shown on the InnoTrans fair last year. It's still a couple of years until these things will be out in the world, sold as a product, but I think everybody is saying this is the future, and in some years from now you won't sell anything without these autonomous features. And from a technology point of view, there are lots of difficult problems to solve in terms of the vision, in terms of the decision making you take when you see an obstacle, and so on. So this is where Siemens goes autonomous driving. The next example is one Roland Busch already mentioned, so I can say a little bit what is behind that. This is about AI for performance optimization, so autonomous learning of a turbine control strategy. Traditionally, it's done, the engineers sit down and they figure out what is a good control strategy, and it's hard-coded into the control system. In this case, it's one of our most advanced cases of applying artificial intelligence. In this case, the control strategy is learned by the artificial intelligence from the data, from the test operation of a turbine. So there are many, many sensors that give information about the state of a turbine, how it's running under various environmental circumstances. And the idea is now in 2 steps to come up with a better control strategy. The first one is to learn how the system behaves. For that topic, we use so-called recurrent neural networks or deep recurrent neural networks. And what they do is they learn to mimic the behavior of the machine under all possible circumstances of environment and control parameter settings. So if you want, you learn a kind of digital twin, but you learn it automatically from data. So it's not one which is designed by the engineer, but one which is really learned from the data of the operation of the machine. And now, if you have built such a digital twin, and then the essence of machine learning is that you can apply it to conditions that you have never observed. So this is what learning is all about. And if you can do that, in the second step, we use a technology called reinforcement learning, which systematically explores this space of unseen control policies and comes up with a better one in a loop of trial and error, good improvements, bad improvements. This is reinforcement learning, and this is the technology, for example, which Google DeepMind used for beating the world champion in Go. So that was also deep learning plus reinforcement learning. Here we use it for gas turbines, for emission reduction, and I think it's one of the very, very few cases where such a technology is really deployed in the field. As Roland Busch pointed out, it's not an easy thing, so it's a critical environment, so if it blows up because of the AI doing something wrong, then you have a big disaster, of course. So you have to be very, very sure about what you're doing. And for that reason, you find very, very little installations of reinforcement learning in critical industrial environment. And this is one of them. It's running in the US, in Asia, and in Middle East productively in gas turbines and bringing down emissions and protecting the environment. Then another completely different application of AI, but also very critical in some stages, is using artificial intelligence for product configuration. So this is about designing a product based on some constraint. The methods that we use here are not from machine learning, but they are logic-based methods, so-called constraint-based logic programming. And the good thing about this kind of technology, it gives you what machine learning cannot give you. It gives you guarantees. It gives you logical guarantees that if your input is correct, your output will also be correct. So this is what logic gives you, and this is what you absolutely need in this kind of application. It's the safe design for railway interlocking control system. So at that stage, you already know roughly what you want to build. You have the equipment your customer wants to buy. You have a lot of regulations you have to comply with. You have some preferences on the pricing of the parts and so on. So a lot of constraints, overall more than 10 to the power of 90 possible configurations. So it's really astronomically huge, your space of possible control systems. And the AI helps you to boil down to a few 5, 10 maybe possible designs that meet all the requirements you have specified, and then you use an optimization step to find the best one. So completely different application than machine learning based on logic, but a truly important one. And this is also, we had the question about knowledge graph. This is in where the knowledge comes in. So this logical based reasoning is built on a knowledge graph which specifies all the parts, how they relate together, what the property are, what can go with what parts, and so on. And so this is where the Siemens know-how on the domain, here the domain of control systems in mobility comes in. And this is a technology I see all over the place. Wherever you have a configuration problem, in principle you can apply this part of methods. And then in the next step, so assume you have built such a control system, you have deployed it in the real world, and you let it run. And then this control system will give you data from its operation, so log file data, sensor data, and so on. And you will find out some of these systems, they work better in practice, some work less good. And the data analytics tells you which one work good, which configurations work good, and which not. And now the very exciting step is you can feed that knowledge into the next design cycle. So the next railway interlocking system you design is based on this knowledge, what works well and what not. And so by that you get a closed cycle of system design, system monitoring, and system improvement in the next design cycle. Again, a very, very broad pattern that you can apply almost everywhere. Coming to my third example, so this is an example actually from India, and I would ask you in the break or after to go to the exhibition where you see the cameras working in the demo. So this is about traffic management in what my Indian colleagues call traffic management in chaotic environments. So chaotic environment is meant to be the traffic in India at times, and the reasoning is that other methods which assume that everybody is driving safely on one lane, that everybody keeps with all the requirements of polite driving and so on, would not work in India. So they came up with a different solution which is based on AI, which is based on deep learning, and which is much more flexible since it really learns from data, and the data is as it is, so it shows real Indian traffic, and they detect cars, pedestrian, people with a helmet, without a helmet in that environment, and it can be used for many different use cases. And this is something we are deploying now in India, but also in other places around the world, in Vietnam, which I guess is also pretty chaotic, but also in Iceland, in Germany. So it's a very good example for a local innovation here from India, which has a lot of value elsewhere in the world. So this is in a kind of POC stage, so working with customers, but not as the gas turbine, a rolled out product which is used in many cases. And so as I said, please visit the booth and you get more information about that, including animated images. And then another example, which is not productive yet and will take a little bit time until it will be productive, but it shows the power and the vision of AI, especially if you combine different technologies. So this is about robots, two robots learning, coordinate, building up a workpiece. And they're not programmed for that, but they learn how to do it. And for learning that, they need two major types of technologies. First of all, they need a knowledge graph, so coming back again to that. So they need to know what I'm capable to do, I as a machine. What are the available parts? How do the parts fit together? And all that knowledge is stored in Siemens systems, in systems like a Teamcenter. So the knowledge is there, and then we use this formalism of knowledge graph to bring it in the right format so that the machines can then reason about that. Reasoning here, again, it's a logical task, it's a planning task, it's not a learning task. But we also need deep learning in that case because the machines, they need to see, they need to sense the environment, and they need to be able to identify pieces, misplaced pieces, and so on. So in that case, the use case is why it is so interesting. It's a mixture of logic-based methods and deep learning-based methods for sensing. And the great vision behind that, of course, the machine learn how to build a workpiece without being programmed, therefore being much more flexible, and then by that coming up with totally different solutions for automation. Now my final example or class of examples is factory automation and the industrial edge. That is, I think, a very, very rich area for use cases for applying AI. The Hella case we heard about before is one case in that instance where optimization is applied on the edge, where the optimization algorithms are running on the edge, or where a vision component is running on the edge, detecting misplaced workpieces, and so on. But we will see more and more cases where AI is done really on the edge in the devices, because it has a lot of advantages in terms of reaction time. So if you need to react very fast, you cannot always go back to the cloud and make an inference there and go back. Or if it's a very constrained environment, you want to do the inference locally so that nobody can interfere. So for cybersecurity reason, it's very good. And that's an upcoming area where AI is increasingly being deployed. Also because of advances in hardware. So more and more manufacturers are offering support for GPUs on the edge, and also Siemens is offering now with a semantic AI-enhanced semantic environments where you can then do much more inferencing than you could before. Now, bringing that together, so we heard about MindSphere as the big ecosystems, IoT ecosystems, running on top of MindSphere. In all these use cases that we put together, we use reusable components for doing the deep learning, for doing the knowledge graph inferences, for doing the planning, and bring them together in one environment, coming increasingly up with so-called pre-trained models. Pre-trained model, that's something where you already did some learning, for example, for traffic management, and then only if you apply what you already did in India, you take the same model, and only the last part of it you have to retrain, for example, for Iceland, giving you a huge benefit in terms of learning time. And this kind of setting, so the algorithm, the AI hardware, such as the semantic and AI-enhanced chips, and the knowledge graph we bring here together in the use cases to being able to quickly deploy new cases with the customers. So what I've shown you in this few minutes is a number of examples of use cases where Siemens is already productively using it, or where we are in POC stage. This is a small selection. Overall, we have more than 200 active use cases at the moment where we deploy advanced data analytics and AI across the company and with our end customers. So it's something that is really getting a lot of traction by now. driven a lot of that from the research and pre-development side is driven from my department in corporate technology, which is about 200 AI and data analytics experts. But the Siemens ecosystem in AI, by now it's much bigger. So there are the people in the IoT unit focusing on analytics. There are the people in the MAX for the mobility and so on focusing that. So that by now we have more than 1,000 people who I would call data analytics and AI experts, not counting all the thousands of software experts, security experts, and so on. So that would go on top. So by now it's a pretty critical mass, I would say. With that, I thank you very much for your attention, and thank you.
Thank you very much, Dr. May. In 2016, Siemens set up a different unit to foster new ideas and to accelerate disruptive technologies. We set up Next47, playing on the idea that Siemens would set up in 1847. We have Robert Hart, partner Next47, to tell us what we are doing in the startup ecosystem and to tell us what is in store for Next47 in Siemens in India. Thank you, Robert.
Hello, everybody. My name is Robert Hart, and thanks for inviting me to this conference. I'm really happy to introduce Next47 to you. And Rami said it already why the name Next47 was created and born. So we are looking together, of course, with our Siemens colleagues, but also with the startup ecosystem worldwide, really for new innovations which really have the potential to elevate Siemens to the next phase. That means Siemens is always and was always an innovative company, and Next47, so with working together with startups and with the startup ecosystem worldwide, adds another element of the innovation processes and innovation ecosystem to Siemens, and of course, and I would like to point that out, to Siemens customers. So, and you see here, so what is very important for us as Next47 is that we put the entrepreneur in the startup in the center of whatever we do. That means put the world to work for visionary entrepreneurs. So that's very important for us. It's very important, of course, for the startups we work with, and it's also very important for you here in the room as customers. How do we bring innovation also to you together with our Siemens organization? So what happened in the innovation world? Why do we have Next47? Why is it so important to look on innovation in an additional and maybe also a different view and with a different point of view? There is innovation paradigm shift. Companies like Siemens, classical industrial companies like Siemens, like you see it also Cisco, Salesforce.com, and so on. So they work together with their customers and produce new solutions, develop new solutions, and then selling it to the industry. So this offers, of course, business opportunities, and you see it here, it's around $1 trillion worldwide, give and take. Can be less, can be a little bit more. On the other side, what we have seen over the last, let's say, 10 to 15 years, so there's a new way of innovation, a new way of creating industries. So that means there's a transformation going on. So why is that? So why is that really developing so fast? First of all, we have new technologies. So we have more computing power. We have the cloud. We have more connectivity. So, and on the other hand, we have capital available, which goes into this innovation and can accelerate innovation because the capital deployed in companies with a different business model and a different, would say, point of view how to use innovation in the combination with the capital deployed for startups. And it's new business models. And I think we all know the example of Amazon. So when that was, would say, created, let's say, maybe 15 years ago, so we saw it as a, would say, electronic bookshop on the internet. Today, it's a total different company. It started with this, would say, first approach, of course, uses the internet, uses, of course, the capital, and also uses really the new business model, how to approach the market. And with that, of course, they start to dominate the book market. Then they start to dominate the retail market. Now they are spreading out into other areas and even in the industrial world. So as you saw in Dr. Busch's presentation, Amazon Web Services is now a partner of Siemens, and they're also in the industrial field right now. So that means industries are radically transformed via innovation, via technologies, via the deployment of capital, and of course also they use new business models. And we as Next47, we look into this sphere. That doesn't mean that we will transform maybe Siemens into a new Amazon or into a new Airbnb. But that means that we learn from it, we learn how to innovate, we learn to create and how to create new business model and transfer that into our world and into our customers' world to create new business value and new opportunities for Siemens and for Siemens customers. So that means we have to be there, we have to learn from it, and we do it by working with those startups and investing in the startups and help them to grow their business and to transfer innovation from the startups into Siemens and into the Siemens customer world. So what is the area of industry transformation and really what is driving the new technology frontier, sorry. So first of all, we have Next47. So we look for technologies who have really a profound impact on industries. We call that deep tech. One topic is, of course, and you heard that, is artificial intelligence. It is advanced robotics, it's cloud technologies, it's virtual and mixed reality. All those technologies, so they are, I would say, necessary to transform our industry to the next level. That's deep tech, and very much when you talk about AI, it's a kind of a horizontal technology. But we have to put that into use in these certain verticals where we are active in, where you as customers are active in. And for that, you need the industrial vertical domain know-how, really to create those applications and to put those technologies then into value for the industries. And you saw that also in Dr. Busch's presentation. With the combination of both deep technologies and industrial know-how and domain know-how, so you can create massive opportunities, create new industries, create new business models, and of course, create new market capitalization. And for that, you also need new leaders, new entrepreneurs on the startup side, but also in our companies who can really adapt those technologies and transform them into new business and new business opportunities for all of us. So how does Next47 actually then work? So we, as Next47, we call it the 3 C's. First of all, of course, we have to identify startups in the areas which are of the strategic interest for the future of Siemens. And when I talk about strategic interest of Siemens, it's also the strategic interest of our customers, because whatever we do is not just for us, because we work together with you and we generate the value by working with you and also create new business opportunities together with you. So that means we deploy the capital by looking for the best world-class startups. And then, of course, what is very important, we have to help the startups really to scale globally. Because just a nice idea and then have an incremental innovation doesn't really move the needle too much for the companies we are working with, and also, of course, what we want to achieve. So that means we have to help the companies to grow and to scale globally. So we do that by working together in the Siemens ecosystem and with the Siemens ecosystem. Siemens is a global company. We are across the world, and we work together with abundance of customers, and you are here. We are working in so many verticals, and that means that is a great potential for startups when they can be connected to those customers. But what we also do, we transfer innovation from the startups into the Siemens world and into the customer's world. That means we make this innovation very practically available for you all here in the room. And with that, we create the value. That means we as Next47, with the so-called catalyst function, we create growth on a global level, and we organize quick and efficient innovation transfer into the customer and into the Siemens world. The third one, what we do, is we foster internal innovation. So we help Siemens innovators to use startup methods, new innovation methods, to create their ideas to a level so that that can be developed faster and more efficient with the Siemens internal R&D processes, but also adapt new business models so that we can generate growth in Siemens and then transfer that to the customer as well. So we do that with a program we call CREATE, and with that we are really starting to see a great momentum in addition to the existing R&D opportunities and processes we have in Siemens. So that means we bring the startup spirit, the entrepreneurial spirit from the startup world, from the startup ecosystem into the Siemens internal R&D processes and the R&D world. So that means with the 3C, I think we have a comprehensive and holistic view on the innovation world, how startups innovate, and add that to the existing Siemens innovation processes and innovation ecosystem. And that really helps us as Siemens to innovate faster and also to be closer to the markets of the future and bring that into good use and create new value for everybody who works together with us. So as I said before, Next47 is tapping into the global ecosystem of startups. That means we have to be global. We have to be where the startups are, where the startup centers, innovation centers, and the innovation ecosystems are. We have to be where also the venture capital potential is. And we have to be where the industries and where the business is. And when you look on this map, so that represents actually where the world of, would say, startups, innovation, and of course also capital deployment in startups is really focusing on. Of course, it's the USA, it's Europe, and it's Asia. And you see here, of course, with Palo Alto, where our headquarters are, and Boston, so that is one of our center. So, and you can imagine, of course, Silicon Valley is one of the most important things where you have, or regions where you have to be. On the other point, Europe is important, and Europe is, of course, not as, would say, easy to tackle like the US, because in the US you have one center, in Europe you have many centers. And now we are expanding to Asia, that means to China, and I think it's now very important, and that's why I'm here, we're expanding to India, to Bangalore. And why is India so important for Siemens and of course for Next47 in this context? First of all, you see the investment in global venture capital is growing tremendously. People said 5 years ago there's a bubble, it will stop, but since then, that time, it's going forward every year. So it's quite interesting that now Asia has overtaken the US in terms of venture capital investment. It comes from China, but it also comes from India. When you see the rise of India over the last 8 years, so there's a lot of new investments in venture capital. It went from 1% to 3%, so that's tremendous. Is it compared to China and the US, where it could be? Definitely not, but we think in 10 years we have a total different picture here. And what is important also, we had 8 years ago 1 unicorn, so companies with a market valuation of more than $1 billion US. Now we have 16 unicorns. So that means those companies are not just growing in India, they grow globally. And when you see the dynamic in the Indian market, so that is not, would say, a straightforward curve, so it goes, from our point of view in the future, exponential. Therefore, we need to be here. And when you look on the deep tech areas where the capital is going, artificial intelligence, so we're 58%, 30 billion worldwide. Autonomous driving and robots and drones, it's very much a software topic. And India is a software powerhouse, And of course, we want to tap into this expertise and into this potential for the future. Therefore, now we open shop here in India, and we will really then work together with our Indian colleagues here and with the Indian startup ecosystem and with you as the customers. So examples of our portfolio where we are already investing in and where we are going to invest in. So, and you see all the, would say, technology fields here, from autonomous, advanced manufacturing, very important, as also mentioned before, cybersecurity, Internet of Things, going down to digital building blocks. So that is where we are investing right now. So we have invested over the last 18 months in more than 16 companies and startups. So, and we have helped those startups also to go into the market and to grow. When you see topics like, I would say, advanced manufacturing, that's quite obvious for Siemens that we are active there. Cybersecurity, as you heard, that's also very important for us, and I will show an example later. But when you, for example, look on vertical software or digital building blocks, so why is Siemens looking into that? You heard that artificial intelligence, I would say machine learning, MindSphere behind that, the abundance of data we are creating. You also need the infrastructure behind that. You need software tools, and also you need storage capacity, which is economical but also high performance. And there we are investing in vertical software, for example, when it comes to digitalizing the processes, of course, in Siemens, but also on the customer side. Bring and Tovo, two examples on the logistics side, helping really end-to-end to optimize and digitalize the entire logistic chain of industrial companies and, of course, also of Siemens. So and that is where we're investing in, and we put all that together and then bring it also to our customer world. And how do we do that? What is the principle behind that? First of all, so we call that creating the value triangle. We always work together in this triangle that a startup, the customer, and Siemens have to be in sync, that everybody sees the value out of that. The startup, we bring them to the customers with a proof of concept. That means innovation to value. Then the startup also to bring together with Siemens, so that helps Siemens. We use the Siemens global setup, and that means we grow to global scale. And then, of course, the customers together with our Siemens colleagues, with the domain expertise and with the startup solution. So that is really then the sector expertise bringing really demand to the solutions and create ultimately the value for all players in this. So maybe three, or maybe let's say two examples for the sake of time. So maybe a question. So what do you think is the expected market volume for 3D printing in the aerospace field? Is it 2.6 million, 9 billion, or 13 billion? A, B, or C? Who's? So it's B. It's a significant number, and that is also why we go into this field. So with a company called Markforged. So there's a 3D printing company, and of course when you say it's 3D printing, it's really advanced manufacturing. So, and we as Next47, so we help them to grow. First of all, of course, we bring them into Siemens factories. 15 or more than 15 printers are in use in more than 15 Siemens business units. So we provide them with expert guidance, and also we bring them to external customers, and you see some prominent names here. On the expert guidance side, so you will see later on also an example at the breakout sessions how we do that. For example, we connected then Markforged with our PLM suite NX, and with that, of course, we use a digital twin principle and bring it together with Markforged to use that you have an advanced manufacturing global platform where you come from one design and can print wherever a Markforged printer in the world is deployed and is in use. Another example, cybersecurity. So how expensive will cybersecurity be if you really don't control that, or if you are not protected by 2021? See? Okay. C, 6 trillion. So it's, of course, it's a number, and it can be very expensive. But besides the money you might have to pay, it also can kill an entire company. So it can destroy your business and also can destroy your customer base. And therefore, we invested in a company called Clarity. So who is protecting the operational assets in your factories, in your chemical plants, and wherever you have operational assets running, which are, I would say, potentially threatened by cyber attacks and cyber hackers. And even there, of course, it was really possible to get Siemens as a customer. So we have more than 4 deployments right now via POC and now via the rollout in Siemens factories. One is Amberg, our, I would say, poster child of automation. Then we have Siemens as a solution partner. We integrated the Clarity solution on our industrial Ethernet components so that we, at the routers, we install in the factories of our customers, so we have a high level of cybersecurity. And of course, we help them in the go-to-market with external customers, with chemical mining, manufacturing, and you name it. We cannot really tell you the names here because, you know, it's cybersecurity, and those companies don't want to be named here for good reasons. So that means we help those companies really to grow, but as you see here, we help them also to innovate and to transfer the innovations into the market, into our customer world. And with that, we create benefit for the startup, we create benefit for Siemens, but I think most importantly, we create benefit and value for you as Siemens customers. So with that, I want to go back to our founder, Werner von Siemens, that ideas, they have, would say, little value if they stay just on the idea level. An innovation without, or an idea or an invention without commercialization and bring it to the market, and without deployment and application, so is not an invention. And therefore, Next47, together with the startups and together with you as Siemens customers, so we bring those ideas into real life, and with that we create together innovation. Thank you very much.
Thank you, Robert.
Thank you.
With innovation, with startups,